Okay, in this lecture video, we're going to look at the Lewis dot structure of polyatomic ions. So polyatomic ions are interesting in the sense that within the atoms of the polyatomic ion, there are covalent bonds. So that means the atoms of a polyatomic ion are sharing electrons. But overall, the number of electrons they're sharing is less than the number of electrons they should have based on their locations in the periodic table. So therefore, that group of atoms has an overall net charge. Okay, so we're going to look at how that works out. So the that we're going to use is NH4 plus. So that is our polyatomic ion, ammonium. So let's add up the valence electrons. We've got one nitrogen atom times 5 valence electrons. Then we've got 4 hydrogen atoms times, times 1 valence electron each. So that's a total, if we had 4 hydrogen atoms and 1 nitrogen atom, that would be a total of 9 valence electrons. However, we're going to have to subtract 1 valence electron because we have a total charge of +1. So that means overall 1 electron is missing from this single nitrogen atom and 4 hydrogen atoms together. So that means we have 8 valence electrons to put on our structure, which is the equivalent of 4 pairs. So let's go ahead and draw out our structure, arranging our atoms centrally about the center, which can never be hydrogen. We connect them by a single bond, and that's our 4 pairs right there. And at this point, we notice that each hydrogen's valence shell is complete. Nitrogen has a total of, let's count them up, 2, 4, 6, 8 electrons available to it, which also completes its outer shell. But then since this is an ion, we still have to use the brackets to show the overall charge. So this is the Lewis dot structure showing the covalent bonding between the atoms of the polyatomic ion for ammonium. So the trick is that you have to have the number of valence electrons in order to have the right number on your structure for the ion. So let's try NO2 minus as our next example. So if you look at the periodic table, nitrogen and oxygen both have a valence shell of N equals 2. So since N equals 2 has an S and P subshells, we need a total of 8 valence electrons to fill their shells. So let's add up what we've got so far. So we've got 1 nitrogen atom times 5 valence electrons. Then we've got 2 oxygen atoms times 6 valence electrons. Then, since we have a charge here of -1, we've got 1 extra electron. So this grouping of atoms has gained an electron overall to give it a charge of -1. So if you add that up, you've got 18 valence electrons, which is a total of 9 pairs of electrons to show on our Lewis dot structure. So in this case, nitrogen is the central atom. So we'll arrange our atoms symmetrically around it, connect them by a single bond, and then we need to mess around here with it, placing our remaining 7 pairs of electrons on this structure so that we get a total octet, or 8 electrons total around each atom. So you might start by just putting lone pairs on everybody. So there's 3, 4, 5, 6, 7 pairs left for a total of 9. But if we do that, we note then that our oxygen here on the right only has 1, 2, 3 pairs for a total of 6 electrons. So that's not going to work. So instead, we're going to have to move one of these pairs into a double bond so that oxygens have access to 8 electrons in their valence shell. So we could write our structure then as like this, and then since this is an ion, we've got to show our brackets with our charge. Or you might have written it in reverse, something like this, with the double bond to the other oxygen atom, and that's fine too. I left my pair off that first one. Make sure you fix that. So either one of these structures is perfectly fine.